In this video, we're going to be talking about quadratic regression. So sometimes real-life data will have a quadratic relationship, but not be exactly quadratic. We can use Desmos to find a quadratic function that best models the data set. So this is going to be really similar to what we did in our previous unit with line of best fit, but now we're just looking at data that follows a quadratic relationship instead of a linear relationship. And so we will do really similar steps to what we did with the line of best fit in Desmos to find this equation. The main difference is step 2, where the equation we're going to type in to get our quadratic equation is going to be y subscript 1 is approximately ax1 squared plus bx1 plus c. So let's look at some examples. So number 1 says the table shows fuel efficiencies of a vehicle at different speeds. So I see that X stands for miles per hour and Y stands for miles per gallon. And part A says to write a function that models the data. So to do this, I'm going to go over to Desmos and type this table in. So if you go to desmos.com/calculator, you're going to hit this plus button, and then you're going to hit table, and then you're going to start typing in the table. I'm going to go ahead and pause the video, type it in, and then we'll finish the rest of the problem. Okay, so I typed in my table here, and now to get the equation of this quadratic, I'm going to type in y subscript 1. So you can either do y, and you can hit the underscore key, so if you do shift dash, which is the left of your plus button, that will give you the underscore. Or you can also use the keyboard here. And so I'm going to hit approximately A, and then if you click X and then click this A, B button, that will give you the subscript. To get out of the subscript, click your right arrow. And then I want to square this plus bx1, the subscript again, hit right arrow, and plus c. And so this pops up for my equation. And so what I'm going to use is this a, b, and c, and I'm going to plug in these values of a, b, and c into the equation y equals ax squared plus bx plus c. Let me go ahead and write that. So y equals ax squared plus bx plus c. And I want to substitute in my a, b, and c. So my a is this long number. I'm going to go ahead and just round this to the nearest hundredth. So that is negative 0.01 x squared. B, again, rounding to the nearest hundredth, is 1.37 x. And then C here is negative 7.14. Okay, and then the next part of this says to use the model to approximate the optimal driving speed. So looking again what X and Y stand for, X is miles per hour and Y is miles per gallon. So the optimal driving speed would be what is the highest miles per gallon you can get for your miles per hour. So I want to look to see where my highest miles per gallon is and look to see what speed I am driving at that. And so this just says to approximate. So going back to my graph, I'm really looking to see what my vertex is. So what's the highest point? And I see my highest point is somewhere around here. Let's say it's right there. And so I see that my highest is 25.9 is my highest miles per gallon, and my speed at that point is going to be about 49 miles per hour. Okay, let's look at this next one. So this one says that the table shows the results of an experiment testing the maximum weights Y in tons supported by ice X inches thick. And so we get this table. My first step is to write a function that models the data. So I'm going to go ahead and type this function in. So I'm going to clear out this table. And so I see for my X, I have 12, 14, 15, 18, 20, 24, 27. And then for my Y, I have 3.4, 7.6, 10, 18.3, 25, 40.6, and 54.3. So I have my table inputted. I already have this set up, so I don't have to type it again. And here I get these A, B, and C values. And so again, rounding to, this time I'm just going to go ahead and round to the nearest tenth. When I write down that equation, I get Y is equal to 0.1x squared minus 0.5x minus 5. Now the next question says, how much weight can be supported by ice that is 22 inches thick? So I have this 22, I have this equation, I know I'm plugging 22 into the equation, but I need to figure out whether the 22 is representative of my X or my Y. Well, it says that's 22 inches thick, and I see that my X value up here is representing ice thickness. So this tells me that X is equal to 22. And I want to know how much weight can be supported by that ice, and my weight is my Y value. So I want to plug that in for X. So I have Y equals 0.122 squared minus 0.5 times 22 minus 5. And I can actually type that whole thing over here in Desmos. So I have 0.122, the square button, minus 0.5 times 22 minus 5, and I get 32.4 tons.